Now we come to the first experiment of the microwave propagation trainer, that is to introduce you to the system. I've already introduced that this is a 10.3 GHz transmitter and we have a 10.3 GHz receiver. We're using a BNC to BNC connector cables for extending the leads of the transmitter end so that the transmitter receiver spacing can be enhanced to more than about 2 meters, and we are deliberately keeping the clutter around the instrument to the minimum so as to avoid any spurious reflections, because we cannot see the microwave, but any metallic objects in around the vicinity of the system will lead to spurious readings and the experiment will be disturbed. We are using a 20 dB connector at the receiver IF output. The receiver has IF out which has a BNC cable which goes to the 20 dB attenuator and which is being fed to the IF input of the instrument. The instrument is taking measurements at the IF which are corresponding to the RF level at 10.3 GHz. The instrument has a double line digital display with a location display of 1. Position being displayed is 0 degree. Step size is 5 degree right now. M stands for manual and 58.5 dB microvolt stands for the received signal strength at this particular position. If we change the receiver polarization or if any object is brought in between, then this receiver level will change. We have the received signal strength indication with a resolution of about 0.1 dB and it has inbuilt damping into it, which allows very precise measurements to be made as compared to uncalibrated VSWR meter. We can see the operation of the instrument. We can go press menu and the memory location starts blinking. We press menu again and the step size starts blinking, and we can change the step size from 5 to 10 degrees to 45 degrees to 1 degree. 5 degree is normally being selected for faster operation. Then we can say manual or automatic. Automatic will move the motor automatically in steps of 5 degrees. Right now manual is being selected. Then we can change the units of the measurement from dB microvolts to dBm. Right now it is being measuring the power in dBm, so it is functioning as a power meter at 10 GHz right now. Depending upon the user preference, one can select dB microvolts or dBm as the case may be. Then RE stands for recall of the memory at location number 1. Then this is reset mode is yes right now. Then S stands for slow. Right now slow is being selected. We can shift between slow and fast modes. Then we can have D stands for counterclockwise. Right now we can change the direction of the motor rotation from clockwise to counterclockwise, whichever is the case may be. Serial mode right now is no. Pressing yes will dump the readings stored inside the receiver into the RS-232 port, which can be analyzed in the software. Now we come to the first experiment. We need to plot the horn antennas, because these horn antennas need to be highly directional. We can plot the horn antenna and by rotating either of the receiver or the transmitter around the goniometer. We need to preferably always be in the far field of operation. Far field at 2d square by lambda. D stands for the maximum dimension of the horn and lambda is the wavelength. So about a meter, meter and a half is the preferred distance between the transmitter and the receiver. Bringing them little closer will result in near field and may result in erroneous readings. The effective point of transmission or effective point of reception inside the horn is the phase center of the horn, which is roughly about 5 to 7 centimeters away from the edge of the horn. we have to use this reference point while taking the measurements of the receiver and the transmitter. So right now we can say that the horn or the receiver is being placed at a distance of about 15 centimeters from the edge of the scale. Now we can change the, right now as you can see 58.4 dB microvolt is the received signal strength. If I change the plane of polarization of the receiver, I need to loosen the screw slightly and I can rotate the horn antenna. As you can see, the receiver reading starts falling from 58, it is 57.9 right now, and it goes falling to I see it has fallen considerably. Right now I'm trying to receive a horizontally polarized wavefront while the transmitter is right now transmitting in a vertically polarized. As you can see, the received signal strength is right now 26 dB, which is roughly 30 dB down from my previous reading, which shows the cross polarization discrimination of our system as roughly about 30 dB, and it also emphasizes the low noise floor of the system, which is showing a level of 26 dB microvolts right now. Now we can again pull it back to